Okay, so today I'm gonna show you how to set up Gaussian calculations on Texas Supercomputer Center. And so basically, first you need this PuTTY software, SSH connection, and so you type in this stampede.tacc.utexas.edu, and you connect, then put in your username and your password. Okay, here you should remember for this server Stampede, there are two directories. One is your home directory, one is work directory. And so you can use FTP to access the home directory. But when you do calculations or submit jobs, you have to do that under the work directory. So now if we do a list, so we have actually two files here. One is a test input file, one is output file. Actually, we can remove this test output file. So here we can take a look at this input file. We can do nano test. And so here in the input file, in the input file here, you change this check file name, and here's the number of processor you use. Here's memory, and generally these are all default. The thing you want to change is the checkpoint file name, and here's a theory level theory you use, the commands, optimization, and frequency calculation. Here's the annotation of your calculation. Here is multiplicity. No, here this is charge. 0 is charge, and 1 is multiplicity. It's a singlet. And here your Cartesian coordinate. And then you save. Okay, so now to submit a job, we need to go to the work directory. So you type cdw and go to the work directory. And in the work directory, we can remove that G09 copy. Okay, so in the work directory, we have this G09 qsub file, this one. And so we can take a look at this file. So basically in this file, we have all these commands you don't generally need to change. So this 16 means this is the number of processors you use, and this is how many nodes you use. And this number you may want to change sometimes. You have a very big calculation, you may want to make the time longer. So now we specify 30 minutes. And this means you load that Gaussian module. You don't need to change anything here, but here you may want to change the directory to your own directory. And now remember, we have the input file under the home directory. So now we do G09 is a Gaussian 09 command, and then you put your directory and also your input file name here, and then you specify the output file to be in the same directory and with log as the output file. Okay, so now we can exit, and we can submit the job. To submit a job, use sbatch, sbatch, and then we use G09 qsub and hit enter. So now it will show you all the status, and so it says submitted batch job, and you can look at the status of the job. You do showq-u and your username, so that will check the submitted job status for that user. So basically the job right now is running using 16 cores, remains at 30 minutes. So now we can do this again, so probably it's gonna be finished very soon. Okay, so while this job is running, well, maybe let's finish this one. So we can, so to look at your path, like current path, you do PDW. And see, now we are in the work path. And to go to your home path, you do CD and PDW. So this is your home path, right? So to figure out your own home path, you need to do PDW. You do CD and then do PDW, and that's the directory you want to use in the job submission file. So now it's probably done, and we can take a look at the files. We do nano test.log. Okay, so here all the Gaussian output files. You can do Control W, and you can search termination. Okay, so this one, the first termination means this is the geometry optimization, right? It's done. And then you can search for the second termination. So this is the frequency calculation. So this is also just finished. So that means this this job is good. It's completed. So to transfer this back, we need to use another software, which is the FileZilla, and double click that. So okay, here we need to type in the I don't remember. Okay, stampede.tacc.utexas.edu, and put in your username and your password. You do quick connect. Oh, seems working. Oh, refused connection. Uh-oh. Hold on. Maybe the address is not right. Stampede. Oh, port. Sorry, I forgot the port. Yes. Port should be 22. Okay, so now you come into this folder, and that's your folder, SSH folder. And so you can see this text file. That's the output file we just generated, and then we can download the file to, say, under C drive. We come to the just overwrite. So I just had one. Okay, so it's here, and then what you can do is you use another software called Camcraft to look at the calculation result. Open under C drive, you open the test file. So this is the water molecule optimized. So here, what you want to check is this abstract. No, let me see. Yes. So this one, the minimized geometry. So here, generally, you would expect to see like yes for all the 4 items here. So that means the calculation is good. And then you can go to the frequency, and also you can check the frequency. They also have 4 yeses here. So this means the calculation is good. And you can see this bending frequency, stretching, and asymmetric frequency, like that. Okay, so oh, here also this is the electronic energy, and that's pretty much it. Okay.